right, hi, my name's Will Richardson, and I'm going to be talking a little bit about almost 20 years worth of chasing kind of the bird natural history angle in aspen stands in the Sierra Nevada, mostly in the Tahoe region. I'm going to talk about some habitat correlates of two different bird indices, bird use, in terms of species richness and abundance. I'll talk a little bit about how aspen serves as a barrier to certain predator groups to nest predation. Some habitat correlates of bird nest success and nest site selection, and then a teeny bit about white satin moths and how they may be impacting that system. So to start off talking about just bird abundance and species richness in aspen, for a 4-year period in the early 2000s, some colleagues at the Point Reyes Bird Observatory and myself set up a great number of transects through the Sierra Nevada, trying to capture many different site contexts, different types of aspen stands that can be found across 4 different major river drainages. And we did point counts, 5-minute, 50-meter fixed radius point counts 2 or 3 times a season through those, just to kind of see what are the main environmental variables affecting bird species richness and total bird abundance. And what we found was that model weights pretty consistently showed lots of herbaceous cover in the understory. It was very important. And then big trees, either large DBH or tall trees, maybe the biggest aspen that you could find. Large aspen were very important indicators of bird species richness and bird abundance, as well as shrubby aspen and some of that aspen recruitment. So across the whole of the Sierra, we basically found that bird diversity, lots of species richness and lots of numbers of birds were positively correlated with the conditions consistent with pure, mature, self-sustaining aspen. And locally, that looks like this. Larger trees and lots of recruitment and very thick herbaceous understory provides incredible diversity of foraging opportunities and nesting opportunities. So lots of resources for a lot of birds. We also found that the addition of conifers into the aspen stands, well, you might think that adding diversity of plant species into your aspen would add increased diversity of birds, but it doesn't. It actually goes the other way. And that corroborates findings that have been found in other parts of the West. And then I, along the lines with some of these conifer thinning treatments that Pascal was referring to, we did some follow-up work to do some pre and post-treatment point counts. And I've done that for a few years, every handful of years, to kind of follow up how the birds responded to those conifer treatments. Obviously, for the sake of the stand itself, it's important to get a lot of that conifer density out of the stand, but what are the short-term impacts and the long-term impacts on the wildlife of going in there and doing those treatments? So we were worried that particularly where there's mechanical thinning, that we might see some immediate negative impacts on those bird indices, followed by a slow recovery. But much to our relief, we actually found that conifer thinning almost immediately resulted in increases in both bird species richness and in total bird abundance. So numbers of birds and even the diversity increased following conifer thinning. So that's a great finding. So I guess if there's one management implication from my talk to recommend, it's don't be afraid of wildlife impacts on your conifer thinning. For the most part, it's going to result in almost immediate positive results. So that was really, really great. I've looked at a number of different things related to aspen as a resource for the birds, but one of the main things that I've been curious about is how the introduction and density of conifers into aspen might influence the predator community that are controlling these bird populations, controlling nest success in particular. And one day we have a lot of chipmunks in a lot of these stands, but you never see them up in the canopy or in the crown. And one day I noticed a chipmunk scurry up a dead log that was leaning against a tree, and it got up about, I don't know, 12 meters up into the canopy and jumped over to the next branch and then fell the whole way. And it really looked like it slipped. And it occurred to me, maybe, you know, that smooth bark, that persistent peridium that the trees have may be too difficult for chipmunks and maybe even Douglas squirrels to climb up in a healthy, undamaged, mature aspen trunk. So I set about to do an experiment a number of years ago to see if that was the case. I had to try a bunch of different things in order to pull this off, but eventually settled on a design of different size bowls, different diameter bowls, and a confined space, and putting different chipmunks into this little this obstacle course of sorts to see if they could run around and climb up the trees. And I used lodgepole pine and aspen at 10 and 25 centimeter diameter bowls. And you know, for the lodgepole pine, these were yellow pine chipmunks. They were able to just climb right up, no problems. They could hide on the backside like a tree squirrel does, and they could descend head first and leap from a static stance, no problem. In the aspen, you know, the chipmunks couldn't do it all. I think 102 out of 107 attempts to jump up resulted in an immediate slip and fall. Occasionally they could catch a little bit of you know, rough bark where a limb had self-pruned or something, but basically chipmunks can't climb aspen trees. Not a clean, mature one. If there's been some physical damage to it due to an injury or maybe browsing on the bark under the snow line, you see a lot of that, then yes, they can get up that. They can get up smaller diameters. But in essence, aspen bark does provide a barrier, or at least an impediment, to small mammalian nest predators. So that's got some implications for the birds themselves in terms of nest placement and added value to putting your nest into an aspen. So I wanted to look at more of the habitat variables affecting nest success in these aspen stands. And we've talked a lot about the problems with conifer encroachment. They overtop the trees, take the sun, take a lot of the moisture out. But they also bring with them a suite of conifer-associated nest predators, particularly corvids and squirrels. And a number of studies have kind of suggested this increased risk of nest predation. And in my point count data, obviously we count Steller's jays, but we've also been counting Douglas squirrels. And we do see increases in both Douglas squirrel and Steller's jays with increased conifer cover at those points. And interestingly, following conifer removal, as part of this, what we were talking about with Pascal's sites, we actually see Steller's jays decreasing at least a little bit. So as conifers encroach into these stands, we expect that the predators will come in and increase both numerically, but also they'll be able to move further into the stand. And so a really large, pure aspen stand may provide a bit of a refuge for birds to be free from any potential predation from those species. And so we would predict that conifer density near nests should be negatively correlated with nest success. And also, with the bark being slippery, we would expect that nest success should be higher in aspen trees than in non-aspen for arboreal nests. So I set up 5 nest monitoring plots back in 2003, and most of these are in the Carson Range of the Tahoe Basin, and started off monitoring all the nests that were available, but pretty quickly settled on the top 5. And these were the warbling vireo, really tightly associated with aspen throughout its range across North America. It just loves cottonwoods too, the populous genus. These tend to be up in the canopy, quite high. Western wood peewees prefer open branches, mid to upper heights of the canopy, but exposed. Robins will be just about anywhere. Dusky flycatcher, which definitely prefers to be in low shrubs, but will nest in mid-size aspen and even right up against the trunk of very tall aspens, quite high sometimes. And then juncos, which nest right on or even, as this picture shows, under the ground. So here are some results from about almost 500 active nests of these 5 focal species. And more than half of those nests fledged young, which is pretty remarkable. Most bird nests fail, and if you can get your nest success around 35 or 40%, then you're going to be making, that's a source population, you'll be making more birds. Most of the failures were due to predation, and for modeling efforts, we only focused on nests that either fledged or were depredated. Here's a big nasty table that shows a daily survival rate and then overall nest survival, but if you focus on the bottom right corners of each, you'll see this is sort of overall survival rate of these 5 species. And you can see at the bottom, you know, we're making juncos in these aspen stands. Vireos, we're doing great. Robins, wood peewees, pretty darn good, making peewees. Dusky flycatcher was the one species that seemed to be doing fairly poorly, and we'll take a little bit closer look at that. So like I mentioned, they tend to nest pretty low, kind of hip high or lower. So these nests tend to be pretty easy to find for biologists, but probably for a whole suite of nest predators as well. I'm gonna skip past that, but here is daily survival rate plotted against DBH of the nest plant. And there's a pretty strong cutoff, or like a threshold around 5 centimeters DBH, where if the flycatcher is putting its nest in a plant that's larger than 5 centimeters DBH, it's probably inaccessible to chipmunks and whatever else is hammering them down low. I also pooled nest fates of 12 different cup nesting species that put their nests in trees, and you can see most of those in aspen did well, whereas only about a quarter of those survived if they were in other trees. This is within aspen stands. So overall, nest success at these sites has been really high, and there's some good evidence that nesting in aspen trees may reduce predation risk from mammalian predators that can't reach you. We did find that near nest conifer density was negatively correlated with nest survival for the 4 species that didn't nest on the ground, everybody but junco. However, we also found conifer density at a larger scale, so within 50 meters from the nest, was positively correlated for juncos, robins, and peewees, I believe it was. And that's a little weird. I've got a lot of ideas about that, but some of the things that may be obscuring a nice clear pattern of nest predation around conifers is that none of our stands is really that big. Tom mentioned, 33 hectares, I think, was his largest stand in the basin. So none of these is going to be completely free from conifer-associated predators. It'd be interesting to do this with a larger look, including out into the Great Basin or further south in the Eastern Sierra, where you've got just pure, huge expanses of conifer-free aspen, and see how that works. And then there's a lot of other predators in this system, so we don't necessarily know if it's all chipmunks and squirrels or corvids. I did have cameras out for one season, and that's a whole nother story, but basically we didn't capture any in the act, and it was only the year after I wrapped that up that I finally caught a Steller's jay robbing this warbling vireo nest. But we have many other predators in these stands because there's so many cavities. Aspen get a lot of heart rot, woodpeckers love them, and that creates a lot of opportunity for secondary cavity nesters like small owls. We have a lot of accipiters. Goshawk is really tied to aspen throughout the Great Basin, but we also have Coopers and Sharpshin in Tahoe. Weasels, and then if you're down near the ground, like the juncos are, you got everybody coming at you. So that's going to kind of obscure the picture a bit. So 16, I don't really have time to talk about this. I'm going to scoot past this a little bit, but we have found some birds are definitely conforming to predictions based on what we'd expect from what we find with nest success. Some are not. Dusky flycatcher is kind of an interesting one. Because they do so much better up high, we would expect that they would, but in reality, they keep almost all their nests. Half of their nests are below 125 centimeters. Maybe the remaining, let's see, another 30% are between 125 and 500 centimeters, and then the remaining 20% or so are up high and out of reach. So why would they do that? Well, again, these are small aspen stands, and so these birds may be constrained by regionally evolved preferences, or this may be more of an adaptive trait from adjacent habitats. Dusky flycatchers will nest just about anywhere. But a big one is that the western wood peewees are probably dominating them behaviorally and kind of forcing them down low. It seems like the wood peewees and the dusky flycatchers sort of partition the forest vertically. So this figure shows dusky flycatcher below and western wood peewee above, and you can see the count of nests by nest height. And western wood peewee is definitely up in the canopy more, and dusky flycatchers just forced down below. So anyhow, we do see some limited evidence for nest site selection as a response to nesting success as it relates to conifers in these aspen, but it really varies by species. And so we may be seeing young, inexperienced birds placing their nests in suboptimal spots. There could be some other factors that there's trade-offs with. And then again, gene flow coming across large spatial scales or adjacent habitat types. In the last couple of years, we've been trying to address satin moths. Satin moth is invasive Palearctic species that hit British Columbia and Massachusetts sometime around the 1920s. And here in the far west, it has sort of spread north and east and then doubled back through Nevada to reach Tahoe sometime around 2012. In the next few years, we started to see it really become quite invasive and defoliating pretty large areas in the Carson Range on the eastern side of the Lake Tahoe Basin. And 2016, 2017, 2018 were really bad years. This is sort of what it looks like. So it'd be a good thing to keep your eyes peeled for these if they haven't hit your area yet. And what happens is they just defoliate the canopy almost entirely. And by midsummer, it almost looks like wintertime. And what that means for the birds is that they just have no cover whatsoever for their nests. And so they're very vulnerable and very easy to pick out if you're a nest predator. And so even from a great distance, you can see. And warbling vireo like that will try very hard to defend its cover, and you can see them picking and flinging the caterpillars off. And you'll end up with this little tiny ball of leaves right around the nest, and then, but eventually they'll eat the last of the leaves, and then that's it. So I've been doing point counts and trying to see if there's an impact on overall bird use associated with this defoliation. And then the last 2 years, been doing nest monitoring in those same sites again, where there was defoliation. So unfortunately, the point counts happen in June, May through maybe early July, and the defoliation is really happening later in the season. So the birds are showing up, and they don't really have much indication that it's going to be a bad moth outbreak year until they've committed to being on territory already. So I'm not seeing really any impact there yet. With all of these, I need to get into the data a lot more, but that's sort of the preliminary look. As far as nest monitoring goes, 2018 was a terrible year, and then the last 2 years haven't been that bad. So my first impression is that it's probably impacting the vireos a little bit. I don't think it's impacting robins or wood pewees at all. Dusky flycatchers, and especially juncos, oddly enough, may be seeing some decreases in nest success. One thing that was very apparent is that the vireos seem to be moving their nests out of the canopy and down to lower levels of the stand, of the forest. And that's because the bulk of the defoliation is happening up in the crown of the trees. And I think they're catching on, and we're seeing vireos shifting their nest heights.
Excuse me.
Yeah.
Are you getting ready to wrap up?
Okay, just one more slide. Well, yeah. So one interesting thing that we're seeing birds from adjacent habitat types coming in to use the satin moths as a food resource. Unfortunately, most of them are keying in on the adult moths themselves, not the caterpillars, so they're not having any impact on the defoliation itself. And then, interestingly, I do think that chipmunk numbers are increasing quite a bit. And here's a photo of a chipmunk eating a moth there. And so that may be what's driving junco nests indirectly to be impacted by these. So In summary, pure mature aspen are definitely best for avian species richness and abundance, and conifer thinning shows no immediate negative impact that we've seen. Aspen bark may be a barrier to small mammalian nest predators. Conifers do predict presence of suspected nest predators, and near nest conifer density been negatively correlated with nest success. And nest placement in aspen trees does increase probability of nest success. Some of the differences in nest predation may be affecting nest site selection relative to tree species, which tree species they're putting their nest in, but not necessarily avoiding conifers nearby. And then vireos may be adjusting their nest site selection in response to the moths. And the moth provides a novel food source for a lot of birds, but that doesn't seem to be helping with the defoliation itself. So need to thank the Nevada Division of State Lands in particular, and also the Lake Tahoe Basin Management Unit for providing a lot of support and funding for this work over the years. So thank you.